Welcome back, friends. All right, we are here for part 2, learning about how to solve simple equations. So, a little review first. We need to make sure that we know how multiplication cancels out, so to speak, when we multiply numbers by their reciprocals. So, we're actually going to answer number 18 first, because to me it's the most obvious what the answer is. So, when we look at number 18 here, by the way, go ahead and try all of these. Pause the video and give them a try. But I'm going to start with number 18. When we look at number 18, we have a 3/4 multiplied by a 4/3. What happens is we're going to multiply across the top and across the bottom, but instead of multiplying this together to get 12 over 12 and then reducing it to 1, we can just cross off a 3 on top, a 3 on bottom, a 4 on top, a 4 on bottom. And what that leaves us with is a 1 over a 1, which is just 1. Okay, and the reason we have a 1 left over is, remember, when we cross off factors, there's always multiplication by 1 on top. So for example, 3 over 4 is really 3 times 1 over 4 times 1. We just don't write the times 1 because it's really unnecessary. But that 1 is always left behind when we're canceling factors out. Okay, so now 17, right above it, is a little bit less obvious because it's a whole number times a fraction, but these are also reciprocals, okay? Remember that -7 in front is actually -7 over 1, and we're multiplying that by the -1 over 7 inside. It does not matter if that negative sign is on top or on bottom or in front. It all means the same. We have a negative times a negative, so those negatives cancel to give us a positive. 7 on top cancels 7 on bottom, and so we are left with just a positive 1, just like before. Okay, so now number 19 just simply says, what is the reciprocal of a number? Okay, so we could say that the reciprocal of A over B is B over A. Or if you want to say it in kind of more like, normal human non-mathematician speak, okay, we could just say it's the fraction but upside down. The fraction turned upside down. I don't know if upside down has a hyphen in it or not, but that feels right. Okay, so all the reciprocal means is flip the fraction over. And the third definition I'm going to give you is the one that's most important for us, which is that it is the multiplicative inverse. So the multiplicative, I'm not the greatest speller ever, that's why I teach math. The multiplicative inverse of the number. And the reason that is the most important is because we're going to be using reciprocals to cancel out coefficients. And by cancel out, I mean that we're going to create a coefficient of 1, which is the identity of multiplication. And that's what the multiplicative inverse does, is when you multiply a number by its multiplicative inverse, you get the identity, which is 1, which is going to be great for us. And question 20, if you answered question 17 and 18 correct, you should be able to see that the product of a number and its reciprocal is 1, because A over B times B over A, those A's and B's cancel out to just give us the number 1. And again, that's the key here. Okay, so now, just like in the first half of the lesson, we have division and multiplication properties of equality. If we start with A equals B, so for example, 3 equals X, then we can multiply both sides by the same thing. Let's say we multiply both sides by 4. This would now say that 12 is equal to 4x. That is also a true statement, okay? So if we multiply both sides of an equation by the same thing, we get a true statement. The same is true on the right side of the screen over here for division. All right, if you start with A equals B and you divide both things by C, we are going to get a true statement still on both sides. Now, technically, we can use division whenever we want. However, I am going to teach this where we always use multiplication by whatever the reciprocal of the coefficient is. Okay, and that's why question 21 is going to come before question 22, is to show us to multiply by the reciprocal. So let's go ahead and zoom in here on 21. What we want to do, just like before when we were solving equations, is isolate the x variable. And so remember, I'm just going to draw this vertical line to keep me organized. And I need to do the same thing on the left side of the line that I do on the right. But my goal right now is to make this x be alone. And in order to do that, I need to multiply both sides by something that gets rid of that 1/7, okay? I want to turn 1/7 into 1. So turn 1/7 into 1. And the reason for that is we want the next line we write down to just have 1x. That way all we have to do is write x. We don't even have to write the 1. Okay, well, how do you turn 1/7 into 1 using multiplication? We just saw on the last slide, you multiply by its reciprocal. So we are going to multiply both sides of this equation by 7. Okay, notice I use parentheses when I'm going to do multiplication. And the reason we're multiplying by 7 again is because 7 is the reciprocal of 1/7. So on that right side, 1/7 x times 7, those 7's cancel to just give me x, 1x. And on the left side, we have to actually work out this multiplication. We have 7 times negative 1/2. That 7 is going to end up on top because 7 times 1 on top, and divided by 2. So what we get here is that negative 7 over 2 is our x value. All right, and if you plug in negative 7 over 2 for x, you will see that you get to a true statement. Okay, when you plug it in, you'll get negative 1/2 equals negative 1/2. Okay, so now for 22, we have two options. I'm going to solve this twice for you real quick. Option number 1 is to divide both sides by 6. Okay, because when we look at 6x, our goal, just like before, is to turn this 6 into a 1. So turn 6 into 1. Okay, we want to make the coefficient of x a 1. That way we have x all by itself. It's just 1x. So I could divide both sides by 6 like this. Okay, and what that's going to simplify to give me is 6x over 6 is just x. And on the right side, 36 over 6 is 6. So we get x equals 6. That is perfect. If you prefer to do it that way, by all means, go ahead and do that. I'm going to show you, though, the other method is to multiply by both sides by 1/6. And the only reason I suggest that we do multiplication by 1/6 is so that way we're always doing the same thing. So on the other side of the screen over here, we were multiplying by the reciprocal, okay? Reciprocal of 1/7 was 7, all right? So that's why we multiplied by that 7 there. So here, I'm just going to recommend that we multiply both sides of this equation by 1/6, okay? Because multiplying by 1/6 is going to cancel out that 6, just like division by 6. Remember, multiplying by 1/6, dividing by 6, those are the same thing. So these 6's are going to cancel. We're going to get x on this side. And then on the right side, 36 times 1/6 is the same thing as 36 divided by 6. So we get 6 again. The exact same answer. Really, we did the exact same thing. But I just encourage you to think about it as multiplication by the reciprocal every time. That way you never get confused when it switches from a whole number to a fraction as coefficient. Okay? If we're always multiplying by the reciprocal, then we just stay in the same habits and every problem looks the same. Okay, so now this is going to cause us to do a couple things all at once. So remember earlier, I introduced that we have SAD MEP. Okay, SAD MEP is how we solve equations, SADMEP, okay, because that is the opposite of the order of operations. That's what we're going to do right here. Okay, so this finally comes full circle. Why I introduced SADMAP, now we're going to actually use it. When we have multiple steps, we want to make sure that we do the subtraction and addition before we do the division and multiplication. Okay, so add and subtract before you multiply and divide when you are isolating variables. So let's go ahead and read my bullet point. When having to use multiple properties, it is often more convenient to use the addition and subtraction properties before using the multiplication division properties. But please be aware that there are plenty of situations that contradict that statement. So eventually we're going to build up experience that tells us how to find the path of least resistance. But for now, SADMEP, okay? Add and subtract before you multiply and divide. So let's go ahead and try 23. If I apply SADMEP, okay, what my goal is, just like before, is to get x by itself. Okay, we are trying to isolate x. So to do that, I could multiply both sides by 4/3, because that's the reciprocal. But I don't want to do that first, okay? Instead, I want to move this 2 right here to the other side first, because add and subtract is going to come before multiply and divide. So in order to move that 2, remember I do the opposite of the 2. So since it's plus 2, I'm going to do minus 2 on both sides. Notice I write it on both sides of that red line. Those 2's cancel on the left. And on the right, we have negative 4. On the left, we just have 3 over 4x left behind. And now that there's no more addition and subtraction to do, now I'm going to multiply both sides by 4 over 3. And notice that when I do this, I put the entire thing in parentheses. Okay? The only reason I'm making a big deal about the parentheses is when we have multiple things to multiply by, those parentheses are going to remind us to distribute. Right now, we don't have to distribute. There's only one piece there, but eventually that's going to matter. Okay, when I do this on the left side, 4 and 4 cancel, 3 and 3 cancel, so I just get x. And on the right side, I have negative 4 times 4 on top, that's negative 16, and I just have a 3 on bottom. So x equals negative 16 over 3 is going to be my answer. And that is a reduced fraction, so we can leave it like that. Okay, 24. We have 2x minus 1 equals 3. I'm going to draw my red line. And just like before, I'm going to do addition, subtraction first. So before I multiply by 1/2 on both sides to get rid of the 2, first I'm going to move this 1 to the other side by adding it. Okay, and again, I add it because it's a minus 1 to start, so I do the opposite. I do plus 1. This gives me 2x, these cancel, is equal to 4. And now because I have a 2 in front of that x, I'm going to multiply by the reciprocal, which is 1/2. When I do that, the 2 cancels out this 2. That's the whole reason we're doing it, is to cancel that 2 out. So we just get 1x. And on the right side, 4 times 1/2 is 4 over 2. Same thing as 4 divided by 2, so that's just 2. So our answer is just that x is equal to 2. All right, moving on. The only difference here is that we're going to multiply or divide both sides before we simplify this time. So this bullet point right here, okay, this second one, said there are plenty of situations that contradict that above statement. This is going to be one of them, where we have 2 options for how we can go about these questions. Oh, by the way, let me correct real quick. There is a typo in 25. There's meant to be a 2 here in front of the x, so we're just going to rewrite this problem, okay, as 7x equals 7 times 2x plus 2. Okay, just going to label that as a typo. Okay, so we could distribute this 7 to both pieces and then solve the problem. But when you notice that you have a 7 that can cancel on both sides, it's actually easier if we multiply everything by the reciprocal of 7 first and then go about the next steps. Okay, so we could distribute this 7, but instead of doing that, okay, we are going to multiply both sides by the reciprocal of 7, just to see that it ends up being a little quicker. So if I do that, both sides by 1 over 7, because that's the reciprocal of 7, what happens on the left side of this equation is nice and easy. 1/7 times 7x just equals x. And on the right side, what happens is this 7 only has to actually multiply by this front 7. Okay, so the 1/7 and the 7 cancel each other out. We're just left with 2x plus 2. The thing that was in parentheses here is all that comes down. Because 7 times 2x plus 2 is all one piece. It's all multiplied together. And so we only have to distribute that 1/7 to the front. We don't have to multiply it by the 2x and the 2, because by multiplying it to that 7 in front, it's already getting connected to the 2x plus 2. Okay, then we only have a couple steps left. We want to get the x's on one side here. So I'm going to subtract 2x from both sides. When I do that, I end up with negative 1x is equal to positive 2 over on the right, because those 2x's cancel. And then in order to change negative x equals 2 into positive x equals negative 2, I just multiply both sides by a negative 1. Okay, so to move that negative sign over, we just multiply by negative 1 on both sides. And that is going to give us that positive x is equal to negative 2. Let me continue my red line down just for sake of clarity here. So positive x is equal to negative 2. Now let me just show you real quick, if we did want to do it the other way. So if we did want to restart, we could have taken 7x equals 7 times 2x plus 2. Okay, that's the original problem. And we could have started this problem off by distributing this 7. If we do that, we get 14x plus 14 over here, and we still have the 7x on the other side. And then we can proceed exactly like normal, okay, exactly the way we did in the previous problems to get to the answer. And what we're going to get to is that x equals negative 2, just like before. So I encourage you, I'm going to leave this to the reader, okay? So finish this off, get x equals negative 2. Okay, that's the answer you're going to get. I encourage you to show yourself the steps in between to make sure you're getting the same thing. Okay, so now the main reason that we multiply both sides before distributing this is really for when we have fractions, like what we have here. I don't want to deal with these fractions. Okay, so the way I can get rid of these fractions is by multiplying everything by a 4. Okay, so the trick to get rid of fractions when there is a denominator like this is to find the LCD, which in this case, 4 and 4, the lowest common denominator, LCD of 4 and 4, is just 4, because they're the same number. So if I multiply everything in this problem by 4, those fractions are going to just cancel out and essentially just go away. So what I'm going to do is I'm going to multiply the left side by 4 and the right side by 4. And what happens is 4 times 1/4 on the left, these just cancel. And so I'm left with the x minus 1 that was in parentheses. And on the right side, 2 over 4 times x times 4. These 4's also cancel. And so I'm left with the 2 that was on top and the x. Look at how nice and easy that equation is now. Now all I have to do is subtract an x from both sides. That leaves me with negative 1 is equal to x. And boom, that's all we had to do to get that one done. So a problem that looked complicated from the beginning, we actually get to a nice easy spot by just multiplying both sides by 4 from the beginning. Had we not done that, okay, so had we kept it as 1/4 x minus 1 equals 2 over 4x, the way we would have proceeded from here is by distributing that 1/4. Okay, so by multiplying this 1/4 in, we could have had 1/4 x minus 1/4 is equal to 2 over 4x. There's nothing wrong with that. This is a perfectly good route to go, but I would argue that this is going to be a lot more tedious to solve because we still have all those fractions in the problem, whereas the way I did it the first time, nice, quick, and easy. Okay, so again, I encourage you to finish this one off, doing it this way. So finish this off and get x equals negative 1, just like we did before. But I'm going to leave that one to you because we already did it in what I would consider to be the easier way. All right, now solve equations that do require simplification. Okay, so we're going to have to actually put a little work into these before we start solving. So we're going to proceed as normal, where we put our vertical red line down. You do already have the skills now to do these two. So I encourage you, pause the video, try these two for yourself before I show you the answer right now. Okay, friends, hopefully you paused the video and now you're back. All right, so on the left side, nothing to do. 8 plus x, leave it alone. That is all good. But on the right side, we can distribute this negative 8 into this set of parentheses. What we're going to get when we do that, we have an 8 in front. Negative 8 times x is negative 8x. And the mistake students tend to make, negative 8 times 2 is negative 16. Make sure that negative sign gets to that 16 also. And we still have a plus 7x in the back. The other side is the same, 8 plus x, nothing changed there. Now I can combine some like terms. Please excuse my little boy Robin barking in the background. All right, so the left side we're going to leave alone, 8 plus x. But on the right, negative 8x and 7x combine to make negative 1x, or just negative x, and 8 minus 16 gives us a negative 8. All right, so now we got to get all the x's on one side. I'm going to add x to both sides. Notice where I write this x. Okay, when I want to move this x over to here, I make sure that I write this plus x underneath this x and this plus x underneath this x. I do not write x underneath the 8 because this would make me think 8 plus x. No, no, no. We're adding x and x together, keeping like terms together. So always make sure you write things on top of like terms. Okay, on the left we have 8 plus 2x now. And on the right, we just have a negative 8 because those other x's canceled. We can go ahead and subtract 8 from both sides. Okay, on the left, again, these 8's cancel. That was the whole point of subtracting 8. We are now left with 2x on the left, and this is going to be equal to negative 16 on the right. I'm going to continue my red line down. And now one more step. We could say to divide by 2 here. Perfectly fine if you want to divide by 2. I prefer to multiply by 1/2. Okay, that's the reciprocal of 2, 1/2. But again, it means the exact same thing. So if you prefer to write division by 2, more power to you. And what this gives us is 1x left on the left. And on the right side, negative 16 times 1/2, or negative 16 divided by 2, is negative 8. All right, number 28. If you did not try number 27 by yourself, please pause the video. Try number 28. But here we go. Okay, hopefully you gave it a try in that half-second pause I gave you. Okay, so now we're going to distribute this 5 on the left and this 2 on the right. So distribute it on both sides. On the left, we get 5x minus 5. On the right side, we get 2x plus 2. And we'll just throw the equal sign in the middle there. I need to get all the x's to one side. So what I'm going to do is subtract 2x from both sides. Okay, what I'm doing is moving these two x's to the left. That way I can get them all next to each other. Once that's done, 5x minus 2x. Again, notice I wrote the x's on top of each other. Okay, I kept like terms together right there. I did not write the 2x underneath the 5 because those would not be like terms. I wrote 2x under the 5x. Okay, when I put those together, 5x minus 2x is 3x. I still have that minus 5, and on the other side, I just have a 2 left over. I'm going to go ahead and add 5 to both sides. Okay, I clearly am underestimating how far I need this red line to be, so I'm going to continue that down again. Okay, on the left side, my negative 5 and positive 5 cancel each other out because they are additive inverses. I get 3x is equal to 2 plus 5 gives me 7. And then now we could divide by 3, but again, means the same thing as multiplication by 1/3. I prefer to multiply by the reciprocal every time just for consistency. And so now I get x on the left because those 3's are going to cancel each other out. And on the right side, 7 times 1/3, I can just write as 7 over 3. So overall, we get x is equal to 7 over 3. All right, we're almost there, friends. So some applications. Oftentimes the difficulty in solving application problems comes not really understanding what is stated. It really is not that you don't know how to solve the equation, it's that you don't really understand what you're reading. Okay, so what we want to make sure we understand is that English takes a lot of shortcuts, but math is very rigid. And so to make problems easier, if we rewrite the English in clear mathematical language, then it translates to an equation very, very cleanly. So let me show you what I mean. Jaden is 41 inches tall. He is 7/8 as tall as his brother. How tall is his brother? Okay, so the question is, how tall is his brother? Whenever I want to answer a question like this, how tall is his brother? In math class, that means we don't know how tall his brother is yet. So let's go ahead and call it x. Okay, so now let's look at the actual middle sentence here. It says he is 7/8 as tall as his brother. In math class, we hate pronouns, okay? Because pronouns are not descriptive. They don't they don't convey the full information. So instead, this word he right here, he is 7/8 as tall as his brother. What that means is that Jaden is 7/8 as tall as his brother, right? He is referring to Jaden. If you know the word antecedent, Jaden is the antecedent of he. Okay, that's what the pronoun represents. But even then, when we say that Jaden is 7/8 as tall as his brother, that's still not really what we mean. We mean that Jaden's height is 7/8 of his brother's height. Okay? So the way we can translate this middle sentence into a mathematical English sentence is that Jaden's height is 7/8 of his brother's height. Okay, so when we say the phrase, he is 7/8 as tall as his brother, we actually mean that Jaden's height is 7/8 of his brother's height. So now why is this so much better? Well, now each word of this sentence means something very specific. Okay, I'm going to start with the two easiest parts. Right in the middle, it says the word is. Is means equals. Okay, is short for is equal to. So Jaden's height is equal to 7/8 of his brother's height. Okay, next easiest part, 7/8 of. 7/8 is just a number. We're just going to copy it exactly where it is. And the word of, you might not know this yet, but of in math is going to tell us to multiply. So is 7/8 of translates to equals 7/8 multiplied by. So now we have two wordy phrases there. Jaden's height, well, we know what Jaden's height is. Okay, Jaden's height is 41 inches, right? We saw that at the beginning. So we can replace Jaden's height with just the number 41. And then his brother's height, well, look at the blue line right above it. How tall is his brother is what we are trying to find, okay? That's what we're saying x is. So x is going to represent his brother's height, okay? So when we do all that, we end up with this equation. 41 equals 7/8 times x. Jaden's height is 7/8 of his brother's height. All right, so now all we have to do is solve this equation, which, not too bad. If I just draw a vertical line through the equal sign, we only have one step here. We have 41 equals 7/8 x. If I just go ahead and multiply both sides of this thing by the reciprocal of 7/8, so 8/7, okay, multiply here by 8/7, multiply the other side by 8/7. We're going to end up with just an x on the right, and on the left side, we got to figure out what 8/7 is. What 8/7 times 41 is. 8 times 41, well, 8 times 40 is 320, so plus 8 is 328. And we have that divided by 7. And I already know that that is not going to simplify because 41 does not simplify with anything with 7, and neither does 8. So the factorization, before I even multiplied, I knew that there was nothing that could cancel out there. But let's be honest. If you tell someone that you are 328/7 inches tall, they're going to look at you like you're a jerk. Okay, that is not a fair way to answer person. So way up here on the top right, okay, I'm going to do 328, and I'm actually going to divide it by 7. Work out this long division real quick. So 7 goes into 32 4 times. Subtract the 28. That leaves us with a 4. 7 goes into 48 6 times. Subtract the 42. That leaves us with a 6. Drop down a 0 here. 7 goes into 68 times. And I'm going to go ahead and stop there because although this keeps going, 46.8, when we're talking about inches, we're going to round this, okay? You're not going to say you're 46.8 inches tall. So instead, we're just going to go ahead and take this, and we're going to say Jaden's brother is about, and I'm using the word about because I'm going to round 46.8 to be 47 inches tall. All right, let's try another one. Gabby bought a used car for $12,000. The price was 3/4 of the original price of the car when it was new. How much did the car cost when it was new? So the question always tells you what your variable is going to be. How much did the car cost when it was new? That's going to be our x. X is going to represent the cost of the car when it was new. Okay, so now let's look at this middle sentence. The price was 3/4 of the original price of the car when it was new. Okay, so the price. Well, what is the price referring to? It's referring to the price Gabby paid. Okay, so we're going to write that out. The price Gabby paid. Okay, and it says was. Was we can go ahead and leave alone. We replace the price with the price Gabby paid. So the price Gabby paid was 3/4 of, and the rest of the sentence is actually totally fine the way it's written, of the original price of the car when it was new. We're trying to find the cost of the car when it was new. Okay, so the price Gabby paid was 3/4 of, and I'm just going to write the original price, or in this case, I'm going to write of the new price. Okay, and I'm putting new price in parentheses just to make it clear. I don't mean new as in the updated price. I mean the price when it was new. And let me actually only put the quotation marks. I said parentheses. Quotation marks around the word new. So the price of the car when it was new. So now let's go ahead and replace things with what we know they are. The price Gabby paid was $12,000. Okay, we already know that. That's what the first line tells us. The word was is the same as the word is. It's just past tense. Okay, so was is going to represent an equal sign for us. And then 3/4 of is going to be 3/4 multiplied by, because 3/4 is just a number. And then of, like I said before, is going to mean multiply. And then the new price, okay, the price of the car when it was new, that is our variable x. So we have $12,000 equals 3/4 times x. Now we can go ahead and solve this thing. If we just multiply both sides of this by the reciprocal of 3/4, so 4/3. On the left side, we're going to get on the right side, we're going to get cancellation. 3/4 and 4/3 cancel, just give us x. And on the left side, we're going to have to multiply 4/3 times 12,000. But if I divide by 3 first, so 12,000 divided by 3 is 4,000, and then multiply by 4, that's going to give me 16,000. Okay, so just a little simplification there. So I can now take this, all right, and say that the cost of the car when it was new was $16,000. And always remember in this class, if it's given to you in words, the question, you need to answer the question in words. I don't always need complete amazing sentences, but I do need context. I need your answer to show me that you know what you were talking about just now.